This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video, I'm going to be deriving the remaining proofs from the trigonometry higher level course, so that would be proofs 4 through to 9. So the first proof we're going to be looking at is cos of a minus b is equal to cos a cos b plus sin a sin b. The first in a long string of the sum and difference formulae in trigonometry. 4 is probably the longest proof of the remaining proofs because the rest rely on substitution based on the previous proof. So for the proof for this formula, we need to look at this diagram shown here, where we have the unit circle once again drawn, so it has radius of 1, and we have 2 points P and Q, which have coordinates cos b sin b and cos a sin a respectively. So that means that this angle here is the angle B, shown in purple, and shown in green here is the angle A. We also need a second diagram here where we take this triangle, shown in red, and take it to the side over here. And there's one thing we need to keep in mind is the angle here shown at the base of this triangle is going to be A minus B, because if you look over here, the angle A and B are both measured from the 0 degrees here. So both angles are measured from this point, which means to get the angle in between the two, which is here, we're going to need to subtract B from A, which is why this angle here is A minus B. So we're going to take two different approaches here. The first is we're going to use the distance formula from point P to point Q. The distance formula being that from coordinate geometry, that the distance between A and B is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared, where A is the point given by x1, y1, and B is the point given by x2, y2. So we're just going to use this formula here with our points P and Q. So we see here we have our point P and our point Q. So we're just going to fill in our x2, our x1, our y2, and our y1 into our formula for the distance between P and Q. Then what we're going to do is we're just going to square both sides to get PQ squared equal to the inside of this square root, because the square root will cancel when we square it, and we just multiply out each of these brackets as well. So this cos squared, cos A minus cos B squared, and the sin A minus sin B squared to get this long equation here. And then we're just going to have to arrange some things around. So we notice here we have a sine squared A and a cos squared A. We also have a sine squared B and a cos squared B. So if we group those two things together, our cos squared b plus sine squared b, as well as our cos squared a plus sine squared a. We can use the formula from proof 1 to write that cos squared a plus sine squared a is equal to 1. Likewise, cos squared b plus sine squared b is equal to 1. And then we'll just have 1, we'll be adding these two values together, so we'll end up getting 2 out in front, which you can see here. So then we just have our remaining pieces, minus 2 cos A cos B, and minus 2 sine A sine B here. And then what we're going to do is we're just going to group, take out a common factor of 2 from these two terms here, this 2 and this 2, to get minus 2 times this. And now we need to do another different approach. We're going to look at our triangle we had up here, and we're going to use the cosine rule on it to find the length of the side PQ up here, since we know this angle and we know the two sides on either side of it, the length of them, which means we can use cosine rule to find this length here, and that is done down here. So just filling in our values, so we'll have A equal to our unknown PQ, B is equal to 1, C is also equal to 1, and our angle, capital A, is going to be that A minus B we had above. So filling in those values here into our cosine rule formula, we'll end up, once we simplify this down, we have PQ squared being equal to 2 minus 2 cos A minus B. So now what we do is we look at these two formulae here. PQ squared equals to PQ squared, which is what we do down here, which means we're going to have 2 minus 2 cos A cos B plus sine A sine B is equal to 2 minus 2 cos A minus B. The 2's out in front just cancel, so our 2 cancels with our 2, and then we can divide both sides by minus 2 to get these to cancel, and that leaves us finally with cos A minus B equals cos A cos B plus sine A sine B. QE.